everyone, welcome to the course on signal processing. This is lecture 5 and in this lecture we will see how the discrete convolution is performed. So first of all, what is convolution? Convolution is a mathematical operator which helps in calculating the output when the impulse response and the input signal are given. So we will see, since we are studying the signal processing and we are dealing with the discrete time of signals, so we have the discrete convolution. Now this discrete convolution can be performed by two ways. One is the analytical approach and the another one is the graphical approach. So by both the approaches we can calculate the convolution of impulse response with its input signal xn. Now this discrete convolution, we will study the properties also. What are the properties of discrete convolution? So convolution basically is a mathematical operator. Likewise we have the addition, subtraction, multiplication, we have a mathematical operator which is called as convolution. So it basically helps in finding the response of the system. Means if we have, in the last lecture also we have seen that if Hn is the impulse response, if Xn is the input, then we can say that the output can calculated as x of n convolution with h of n. So this is basically a convolution operator. So with the help of this convolution we can basically calculate the output of the system. Now we have a small property also that convolution in one domain results in the multiplication of the signal in another domain. Means we can say that if here we have the convolution in time domain, so definitely if we are going in z domain or in frequency domain, so definitely there will be the product, right. So x of z multiplied by h of z, or what we can say x of e raised to power j omega multiplied by h of e raised to power j omega. So the convolution in one domain results in multiplication in another domain. Now here we have written that x1n and x2n, if they are two signals, how can we calculate, how can we perform the convolution of both the signals, both the discrete time signals. So we can expand this as a summation k equals to minus infinite to infinite x1 k multiplied by x2n minus k. Later on we will see the properties of the convolution, where we can see that we can write down this as x2 k multiplied by x1 n minus k also, we will see. So here we have the system having an input xn, impulse response hn, so output is yn. So as per the definition of impulse response, the definition says that if xn is an impulse signal, so the response means the output of the system can also be known as impulse response. Likewise we have a definition for step response also. So the step response says if the input is a unit step signal, means un, so the response can be called as step response. And likewise we have the ramp response also, which says that input is a ramp signal Rn. So definitely we are getting a response which is known as ramp response. So generally the step response and the impulse response, they are quite important, because with the help of these two we can basically check the properties of systems, that whether system is linear, non-linear, variant, invariant, causal, non-causal, stable, unstable. So what we are writing here is that y of n equals to x of n convolution with h of n, and which can be further written as this. So what are the steps? What are the basic steps in the convolution? So we can clearly see from our last equation that first of all we are just making h of n as h of k, or basically we are first of all performing h of minus k, means we are just mirroring the system. we are just putting h of n, we are just putting, instead of n we are putting minus k. So, next is we are performing the delay also, delay, and we are just multiplying by this as x of k, and further we are just performing the summation. So, convolution operator basically consists of these three steps, these four steps. First is the folding, which is called as mirroring also. Next is the shifting, so it will make you h of n minus k. Next we will multiply by x of k, which is the multiplication step, and finally after multiplication of h of k and x of k, we are just performing the summation. So, these are the basic steps which helps us in finding the convolution summation of two sequences. Now, we are starting the properties of convolution. So, as we can say here that we can write x of n convolution with h n, or we can write h n convolution with x n, means we can interchange x n and h n. So, this property is called as commutative law. This law is called as commutative law. So, how this commutative law is helpful basically? So, while performing the convolution summation, if let us say x k or x n is a complicated type of signal and h of n is quite a easy signal. So, what we can say, equation 1 will help us. Now, if h of k or h of n is a complicated type of a sequence, so these two steps, means shifting and what we can say the mirroring, is not possible, it is not easy here. So, what we can say, we are going for equation number 2, means if this is a typical signal, we just perform h of k, and if this is an easy signal, we just perform x of n minus k, means depending upon our flexibility, we can just interchange x of k and h of k. That is called as a commutative law. Next is the associative law. What this associative law says, that if x of n convolution with h of n, and we are further performing the convolution with h to n. So, what we can say, that we can just start with the convolution of h1 and h2n, and whatever is the result, we are just further performing the convolution with xn. So, this is called as the cascading of two stages. So, we have let us say h1n here. So, y1n is basically xn convolution with h1n, and further what is yn here, h2n convolution with y1n. So, if we are interchanging basically, so we can club these, we can club h1n and h2n, which is called as the cascading. Just perform the convolution first for the impulse responses, and further we just provide the input xn to evaluate the output of the system. This is called as associative law. Next is the distributive law. So, what we can say, that if we have h1n plus h2n and the whole term is convolved with xn, so it can be represented as xn convolution with hn plus xn convolution with h2n, means we can break this. So, this is something treated as that we have a parallel system having an impulse response h1n and h2n, and both the impulse response having a input which is xn. So, first we will perform the convolution, and finally we can just place a adder over here to calculate the output. So, by seeing this type of diagram, what we can say, that the system is connected in a parallel manner. So, this is a parallel interconnection of individual systems h1 and h, h1n and h2n. So, these are the three laws which are associated with the convolution operator. Now, how can we perform the convolution of two finite sequence, because this is quite easy when both the sequence are of finite duration. Next case what we have is that we have one finite sequence and the second sequence is infinite duration. And the third type of problem is that we have both the sequence are of infinite duration. So, that is bit complicated. So, what we are given is that xn equals to 1 for all n between minus 1 and 1, and hn is also 1 for all n between minus 1 and 1. Otherwise, both the signals xn and hn are 0, means less than minus 1 and greater than 1, the sequence is 0. So, first of all we are starting with yn equals to our important equation, that k equals to minus infinite to infinite x of k and h of n minus k, or we are starting with the second equation, because both the equations xn and hn are supposed to be a simplified form, both are in a simplified manner. So, we can use either this way or this way. So, first of all we just plotted the sequence xn, so that we can clearly see what are the values at n equal to minus 1, 0 and plus 1. Also for hn this is also identical. So, by expanding the previous equation for n equal to 0, when n equal to 0, so we are getting y of 0 equals to summation k equal to minus infinite to infinite x of k multiplied by h of minus k. Now, just expand this. When let us say k equal to minus 1, we just expand from minus 1 to plus 1. So, we are having x of minus 1, h of 1 plus x of 0, h of 0 plus x of 1, h of minus 1. We are having some terms over here, we are having some terms to the left, but those terms will be definitely 0, because the signals are 0 over here, here and here. So, no need to write down those terms. Now, we will see x of minus 1 and h of 1, x of minus 1 the value is 1, h of 1 the value is 1. Just put these values in this particular equation, what we are getting here is 3. Similarly, when n equal to 1 we are having y of 1, when n equal to 2 we are having y of 2. So, what we are having y of 1? Y of 1 will be summation k equals to minus infinite to infinite x k multiplied by h of 1 minus k. Now, we will start putting the values of k. So, first let us say k equal to minus 1, so we are getting this x of minus 1 multiplied by h of 2. Now, we are putting k equal to 0, we are getting this particular term. When we will put k equal to 1, we are getting this term. Now, the next term will be let us say x of 2 and h of minus 1, but no need to write those terms. Why? Because here h of 2, what is h of 2? Clearly h of 2 we do not have the signal, means the signal otherwise is 0. So, we can put 0 and this term will definitely be 0. Similarly, over here x of 2, again as per the given question the xn is 0, so this term is also 0. So, we are getting only the output corresponding to these two terms, this term and this term. So, we are putting the values and we are getting output equal to 2. Next, for n equal to 2, whatever we have performed in the above two steps, we are going to repeat for n equal to 2 also. So, we are getting output y of 2 equals to 1. Now, similarly, some further values n equal to 3, 4, 5, 6 so on, definitely you are going to see that the output y of 3, y of 4, y of 5 is going to be 0, because the signal is not overlapping at that particular moment. Now, when n equals to minus 1, minus 2, minus 3 and further, if we will try to evaluate, so at n equal to minus 1 in a similar fashion we will be calculating that the output is 2. Here for n equal to minus 2 the output is 1, and beyond minus 2 let us say for n equal to minus 3, for minus 4, minus 5 and all towards minus infinite we are getting an output which is supposed to be 0. So, we can clearly see that the output yn exists for n equals to minus 2, minus 1, 0 and further 1 and 2. So, we are getting output at 5 particular points like this. So, if we are plotting this output yn, so this value is 1, this value is 2, 3 and so on. So, what we have obtained here is that if we have a square signal like this, 2 square signals, so we are getting a triangular type of signals. So, the convolution of 2 square signals results in a triangular pulse or triangular waveform. Also, one important point here is that let us say input signals are starting from -1 to 1, the second signal starts from -1 to 1, then definitely at the output will starts from by adding the lower limits and the upper limits. So, if we will add the lower limit, it will be -2, the upper limit it will be +2, whatever is the shape. We are not interested in the shape, but we can say that the output exists for n equals to -2 to 2. So, by seeing this small result, we can check that we are getting output and what is the range, means for all what values of n the output is going to be exist. So, this technique definitely helps in objective also. Now, by completing the analytical method, now we are going to start with the graphical method. This method is also very helpful when one signal is finite and the another signal is of infinite duration. So, definitely this graphical technique will helps us. So, how this technique work? First of all, we are going to draw xk and hk. Now, instead of xk, instead of hk, we are putting h of minus k. How we are going to put h of minus k? We just perform the mirror image about the vertical axis. So, vertical axis, since the signal is symmetric, so it will not affect, the signal will remain same because the signal is also an even signal. After that, we will multiply h of minus k by xk. This is for n equal to 0. After that, we will just perform the delay. So, h of minus k will perform the delay h of 1 minus k. So, definitely the waveform will shift in this particular direction and again will multiply by xk. So, let us say if we are multiplying by xk, we are getting a same type of signal because we are having xk, xk is also same, xk is also 1 for n equals to -1 to 1. So, if you are multiplying this signal by this signal, you are getting a same type of signals. But if you are multiplying by the shifted version of this signal, so we are getting only multiplication available at these two particular points. At n equals to -2, we are not getting the signal. So, we are getting only 2 peaks, here we are getting 3 peaks, and in the next step we are going to perform the summation of these 3 peaks, 1, 1, 1, 1 plus 1 plus 1, definitely it will give you 3. So, when n equal to 0, we are getting output is 3, when n equal to 1, we are getting output equals to 2. Similarly, for n equal to 2 and n equal to 3, if we will perform the multiplication graphically, so you are going to see that at n equal to 2, we are having only a single peak, but when n equal to 3, we are not having any peak, means the output here, output y of 3 will definitely be 0, but here what we can say that the y of 2 is said to be 1. So, we have considered the positive values of n, also we need to consider the negative values of n, which is -1, -2, -3. So, at -1, now we are going to shift the signal towards left, this side, and will perform the multiplication. So, we are getting only 2 peaks. So, the result y of -1 equal to 2, and here we are having y of -2, we are having only single peak equal to 1. So, this is at n equals to minus 2. Similarly, at n equals to minus 3 we are getting output, we are not getting any peak. So, that is why definitely y of minus 3 is 0. So, we are having values from n equal to minus 3 to plus 3. Now, we are going to plot the output here. So, at n equals to minus 3 output is 0, at n equals to minus 2 the output is 1, further 2, 3, again 2, 1. So, we have obtained the convolution of two signals, two finite duration signals with the help of graphical technique. So, this we have already identified 3, 2, 1, 0, 2, 1 and further 0. Now, we have the next case. If we can see that xn equal to un, xn is a unit step signal which exists from n equal to 0 to infinity. This is un, xn equal to un, and this is hn equals to a raised to power n un. A raised to power n, also it is given that a is less than 1, means if a is less than 1 you can assume that a is half 1 by 2. So, 1 by 2 un, initially we have let us say 1, after that we have a square, a cube and so on. This is what we have is hn. So, we need to perform the convolution of hn and xn. So, how can we start performing this? Now, it is having infinite number of points to the left, to the right here and to the right here. So, output also we are having infinite number of terms. So, how can we solve this? So, the answer is graphically, if we will obtain graphically, definitely will be achieving the result. So, first of all, if we will put n equal to 0, we are having hk and x of minus k. So, hk, this is hk, x of minus means opposite if you are performing the mirror image. So, only you are getting, after multiplying you are getting a peak which is 1 like this, right. So, we are getting a peak which is 1, which is at n equal to 0. Similarly, when we will put n equal to 1, so we are having y of 1 equals to h of k multiplied by x of 1 minus k. So, let us try this, h of 0, x of 1, we just expand this and we will put the values. We can say that we are getting 1 plus a. Also, the condition is given that the magnitude of a is less than 1. So, we will see later on what is the requirement of this particular condition, right. So, if let us say if a is greater than 1, so it will basically this signal is going, the signal is diverging something like this, right, and the convolution, the output definitely will approach towards infinite. So, this is diverging, this is basically converging at a particular point and this is constant. We will try to see what is the shape of the output. So, at n equal to 1 we are having 1 plus a, at n equal to 2 we are having h of k x of 2 minus k and put the values of k over here. So, we are getting 1 plus a square. So, let us say when n equal to 3, what will happen n equal to 3? Likewise, we can see here that when n equal to 1 we are having 1 plus a, when n equal to 2 we are having 1 plus a square. If n equal to 3, so we are having here is 1 plus a square plus a cube. For 4, for n equal to 4 we are having 1 plus a square plus a cube and a raised to power 4. So, what we can write? We can write what is the nth term. So, yn equals to starting with 1 to a raised to power n. So, we have the signal, we have the sequence, output sequence as yn. Now, what is the summation? As we are already aware about the finite summation and the infinite summation. So, here we can say that it is a finite duration summation. So, finite duration summation is we have 1 minus common ratio. What is the common ratio over here is a. So, 1 minus r raised to power n plus 1 divided by 1 minus r. This is a small relationship, r raised to power n plus 1 divided by 1 minus r for finite. For finite sequences. For infinite it is nothing but 1 upon 1 minus r, or basically a by 1 minus r. So, we are having a summation yn. Now, for n less than 0, when n is less than 0, yn, what is yn? We can say the yn is 0, and when n approaches infinity, we can say if n approaches infinity, so what we are getting means we are performing the infinite summation. These terms are infinite, and once these terms are infinite, we have the summation is 1 by 1 minus r. This is for infinite. So, we are having 1 by 1 minus a, means what we can say that if we are going to plot the output sequence. So, initially we have 1 plus a, means we are adding something, a is less than 1 although, but once you are adding into a into 1, we are getting a value which is quite high in comparison with 1. So, further we have 1 plus a square, further a cube plus a raised to power 4 and so on. So, naturally this curve will go something like this, and last value what we have is when n approaches infinity, it will be 1 by 1 minus a, whatever we have obtained over here. So, this is again we have used basically the analytical approach here, but we can use the graphical also. So, by graphical technique what we can say, first we will perform the mirror image of the signal, after that we will perform the delay in the signal which is x of n minus k, and we will try to obtain the convolution summation. So, this in both the cases Hn and Xn, both the sequences are of infinite duration, and we have performed the convolution of these two discrete sequences which are of infinite duration. So, if one signal is basically a finite and another one is infinite, so also that is quite easy case. So, yeah, this is the output. Yeah, these are the references. Thank you.